Hello, and welcome to part 2 of Making Sense of Mechanics. In this video 2.1, I'm just going to go through a sort of a short warm-up activity with you, something that you'll be able to try in your classroom. I recommend you do with your students, and that will help also to review the concepts that came up in part 1. So let's move straight on to what this activity is about. What can you do in the classroom? Okay, now I recommend you actually try playing along with this, as it were. Imagine you are one of the students as I'm leading this activity. It'll help you get a better feel for it and also help you reflect on, will this work in your classroom? Because remember, every teaching activity, no matter where it comes from, who explains it, you will always need to do some adaptation to your students, your classroom, your resources. Okay, let's get started. First of all, just need one hand. Show me one hand and turn the palm towards me. Excellent. And show me 0 fingers. Good. 4 fingers. Good. 5 fingers. Good. 1 finger. Okay. A bit silly. Maybe you've already used that for answering other kinds of questions. Of course, you have to be a bit careful asking for the 1 or 2 fingers, but palms towards me helps to mitigate any unwanted side effects there. Okay, so the mechanics time. Breaking one of my own rules right now, just because of the resources I've got at home. Usually nothing that rolls or bounces, because that's a nightmare in the classroom. But here's a ball, and I'm just going to place it on the palm of my hand like that. And I'm going to ask you to think about how many forces are acting on the ball when it's there. Okay, so like I say, my palm's horizontal, the ball's just resting, not moving at all. How many forces are acting on it right now? So have your thinking time, and then show me how many forces. Okay, now at this point you're going to be looking around the room. In an ideal world, every single student will have the correct answer, the same answer and the correct answer. In the real world, you'll probably see a variety, and I can imagine answers from, say, 0 to 3, perhaps. I can't think of anything much more extreme than that. What I suggest you do is start with the 0s and work up to the 3s and then back down again. Okay, so what I mean there is, Billy, you said 0. Tell us about that. And they might explain, well, it's not moving, it's not doing anything, there's no motion. So maybe that student believes there's no forces acting right now. Okay, next student. Jane said 1. Okay, talk to us, Jane. Well, it's got mass, there'll be a weight force acting on it. Okay, there's an idea. Do that thing of not agreeing, disagreeing, not saying yes, not saying no. Keep that discussion going through the students. Someone that said 2, they might talk about the weight force and perhaps a normal reaction, supporting force. Okay. Someone that said 3, they might talk about the weight and the normal reaction again. They might add in friction. Okay, that's interesting. So we've gone up from the 0s to the 3s. Now we're going to go back down again. So go back down to a 2 and say, well, okay, you said weight and normal reaction. And Fred here says friction. What do you think about that? And then you can start to tease out these changes. Well, there's maybe no friction because it's not moving, it's not trying to move. I'm going to stay with my original answer of 2. Back down to the 1s. Well, you only said weight. What do you think about this normal reaction? Oh yeah, I can see it's resting on a surface. There'll be a supporting force. There'll be a normal reaction force vertically upwards from my hand. Back down to the 0s even. You said no forces at all. Now you've heard these ideas. Yeah, okay. And slowly through that kind of discussion, hopefully you can get the room agreed on that correct answer of 2 forces. And it could be a good opportunity to remind them of the 4-part description we use. Here's the arrow again. There is a weight force acting vertically downwards on the ball due to the earth. There is a normal reaction force acting vertically upwards on the ball due to my hand. Okay, name of the force, direction acting on the ball due to the other object. Okay, next round. What I'm going to be doing next is throwing this ball up slightly and catching it again. Okay, and I want you to focus your attention on that highest point that it reaches at the top there. So what I'm going to ask you in a minute to think about is how many forces are acting on the ball when it's at that highest point in its motion, when it's there. Okay, how many forces are acting on the ball when it's up there? I'll throw it once more and then I'll ask for your answers. Okay, show me how many forces. And once again, okay, break out of character now, you'll see answers perhaps in the range 0 to 3 again. Start from the zeros, up to the threes, back down again. Very quickly, zeros, perhaps that idea again, it's not moving, nothing's touching it, it's not doing anything. Might even say it's momentarily at rest, it's instantaneously at rest up there. Could be someone's justification for saying 0. The ones, probably going to talk about the weight force. The twos quite often talk about the weight force and, well, it got up there. Okay, I did something with my hand. So there's an upwards force of some kind from my hand and the weight force acting downwards. The threes, if you get as far as a 3, maybe even mention air resistance. And you can say, okay, but remember, we neglect air resistance in our modelling. Okay, so if that was your reason for saying 3, if we neglect air resistance, would you like to move down to be a 2? Okay, great. And then the twos and the ones, you can fight it out again, have that discussion developing without you leaping in and saying yes or no, right or wrong. Okay, now, why is this such a good activity for recapping our last week's session? Because it reinforces this principle. The only force we study that acts without physical contact is weight. So when the ball is up there, nothing is physically touching it. It will just have a weight force acting vertically downwards due to the earth. Okay? There's no other physical contact. There can't be another force. I'm not touching it when I throw it and put it up there. I'm not touching it. No force from me. Now, yeah, you could say, well, I did throw it. What about that? And down in this moment, down here, yes, I'll be applying a force. There'll be an upwards force from me and a downwards force from weight, because I need to get it moving. I need to give it some momentum to get it started. But as soon as it leaves my hand, okay, a millimetre above, or less than, as soon as it loses physical contact with my hand, I can't be exerting a force on it. So there'll just be that one force of weight acting on the ball when it's up there. So 1 is the right answer. Let's quickly look at that. So there's the tennis ball, and there's that single weight force, that force diagram showing one force acting on it. Okay, so as I said, that's an activity that you can run. I recommend you do run it in your class. Tends to be a useful one. They remember it. Well, mine remember it because it's about the only one I do. Okay, it sticks in their memory, and it's helpful to refer back to that down the line. While we're here, just one final thought. With this same ball, this same diagram, if all you're given is this force diagram, I'm going to ask you, well, in which direction is that ball travelling? We need to be careful here, because you'll be forgiven if every fibre of your intuition and your instinct is saying it's going to travel downwards. Okay, it's got one force arrow. The force arrow is pointing downwards. Even just visually looking at it, it looks like it wants to fall. It wants to just slide down off the screen down to the floor. All right, but that's not true, and we've just seen why. Because remember, this ball, as soon as it leaves my hand, all the way up and all the way down, there's just that single weight force acting. So this diagram could be of the ball on its way up. It could be of the ball just at its highest point. It could be of the ball coming back down again. Okay, so it's a subtle point, and it's where we have to really detach ourselves from any intuition or instinct that you want to attribute to this ball falling. Okay, but the point is, from a force diagram alone, we cannot decide which direction that object is travelling in. And that's an important little point, so I wanted to make that now. Okay, that's the end of our recap, and whenever you're ready, move on to section 2.2, which is where we're going to take a really careful look at force diagrams and good habits there.